Interesting. Okay. Oh, sorry. So, we are going to be talking about the abacus. And am I all set? Okay, I'm all set. Good morning, good morning. Hey, hi, good morning. We're talking about the abacus, and I don't know if you know what an abacus is. Do you know what an abacus is? Hi, good morning. The first one here. I have time to say hi. All right, so what are we doing here? Hi, good morning. Come on in, come on in. We're talking about the abacus, and this is a counting tool. This counting tool helps me understand how to read numbers. So this would be about like learning how to do math. And so on the math, we're going to be learning how to do count. So on the abacus, this is an abacus. This is my counting tool. With this counting tool, the first thing we need to do on the abacus is to understand how to read it. When we understand how to read it, we can actually do adding, subtraction, multiplication, division. We can actually do all the arithmetics on this little thing right here. Now, what is this? Again, this is what we call the abacus, and I'm hoping everybody can hear me. This abacus is what we can use to count. So the first thing we're going to do is figure out what the numbers are. So all of these beads, right? We have a horizontal bar, and underneath the horizontal bar is called the lower beads. All the lower beads has a value of 1. So when I count it, it'll be 1, 2, 3, 4. Just like on a die, we know this is 4. 1, 2, 3, 4. So here on the abacus, this is 4. 1, 2, 3, 4. Hi, good morning, everybody. Come on in, come on in. So here, when I add 4 to the horizontal bar, this is what we count as 4. The other beads are not counted. Why? Because they're not touching the horizontal bar. The horizontal bar is the key. The horizontal bar is the key because that's what keeps us understanding what is what, right? So in this scenario, we have only 4. Now, why do I start here? The reason why I start here is because I have a dot. This dot, if you notice, is a what do you call it? Is a label. It's a label to tell me that this is going to be my ones place. So here we're talking about the ones. So this is going to be 4. 1, 2, 3, 4. Easy, right? Easy peasy. Easy to understand, simple to use. I'm going to coin that one. Why? Because when we look at it, it's easy to move. So if I did this, right, I have another set of dots here. So this dot and this dot, they're same. The only difference is which one do I want to say is my ones place. So if I say that this is my ones place, then this will be 4. If I say that this is my ones place, then this will be 4. So it actually doesn't matter which dot it is, but it's also nice to have another set of dot. Now the reason why is because when I do this, now we could say it's the thousands. Just like we have group separators with the commas. What does that mean? Well, when we do group separators, when we do like, so this number here that I did, it was 4,000, comma 004. See how there's that group? Oh, that's not good. Come on, come on. Okay, see how there's a separator? That separator helps you know that we're counting, right? Because it's a little much if we just keep it all together, right? So it's just easy to see. The dots are the same way. So my 4 and the 4. So this is the ones, the tens, the thousands, the thousands. Ones, tens, hundreds, thousands. Let me take that slower. So that's what this is. Now, this is 4. How do I know that this is 4,004? 4,004. I know this because those are the only beads touching the only beads touching the horizontal bar. When the beads are touching the horizontal bar, then we know that it's being counted. Good morning, good afternoon, good evening, good day to everybody that's in the room. Thank you for joining me. We're just talking about how to read the abacus. And why do we want to know? Because we can actually do arithmetic on it. We can actually do adding, subtraction, multiplication, division. But the first thing we need to do is we need to understand how to read it. When we learn how to read the abacus, then we can go further on to understand how do we add and subtract on the abacus. What if it's 5,000? Ooh, that's a good question. So for 500, 5,000. So what I said here was this is all the 4 beads. All the 4 beads, and notice that there's no 5, right? So the 5 is actually up here. This will always have the value of 5. Thank you so much for the comment, Dave. So this is going to be 5. That will always be 5, no matter what we're talking about. This is 5, this is 5, this is 5, this is 5. Right? So now the question is what is 5,005? So 5,005 looks like that. How do I know? Because all the top bead is touching this horizontal bar. If you notice, none of these top beads, what's considered top is anything above the horizontal bar. Anything below the horizontal bar is called the bottom beads. in Abacus world, they call it heaven beads and earth beads, or we could just call it top beads and bottom beads. Now it's in the relationship of the horizontal bar. The horizontal bar is what keeps everything organized. So when we continue on with the thought process, right? Remember, the dot means that we are talking about the ones place. So if I did my ones place here, that's great. But if I change my ones placed here, what would the number be? Put it in the comments what number you think it would be if this is the ones, just like we write in regular math, just like we write it, right? What do we know what this is? So if we know that this is 5005, what would the if this was the ones place, what would it look like? Well, it would look like this, 0.05, almost. Because we still have a 5 over here, don't forget that 5, it would be 5, because this would be my ones place, 0.005. How do I know? Because just like this decimal does not take a place of a place value, Anyways, that's a little redundant, but it doesn't take a place in the place. What it does is it sits between the two columns, just like right here. So when we do the decimal, just like how we write it, it sits between the two. So we have our ones, our tenths, our hundredths, and our thousandths. Now, the only reason why is because I said that this was going to be my ones. But it doesn't matter which one could be ones. It actually really doesn't matter. It could be wherever you want it. So this is a smaller abacus. This is only 7 columns. But if I had a bigger abacus, where would I usually start if this is a bigger abacus? This is a 13 column abacus. And so what I would do is usually I would start in the middle. Abacus is too hard for me. No, Andrew knows abacus is not hard. Abacus is easy to use. Easy to understand and simple to use. But the first thing we all need to do is we need to learn how to count it. We need to read it, right? So we count 1, 2, 3, 4. So when we do that, we know that this is 4. How do I know? Because the abacus horizontal bar is touching the beam. If these colors are too much, right, it would be nice to have these ones. Why? Because it's all the same color and you don't get so distracted. It's not overwhelming, right? And so here, this is the 13 columns. In the 13 columns, I would like to start in the middle. Why? Because I have more numbers to here and I have more numbers on this side. So this would be like more numbers for the whole numbers and more numbers for the... If you knew you had a big number, you could start from all the way over here. And again, if you see, there is the dots, right? So let's count the dots. If there's 13, what we can do is a big, huge number. So if I start here as this is my ones, tens, hundred, thousands, right? 10,000, 100,000, million, 10 million, 100 million, trillion, 10 trillion, 100 trillion. No, I just missed one thing. Billion. I think I missed a billion somewhere. So it's a billion and a trillion, right? So so that's how the columns work. The columns are just place values. So when we look at it, we're back to here because I like the colorful ones and it just made more sense. You know, when I teach children, and the students that I teach are about 3, 4, and 5 right now, but I do starting to get children that are 7 years old, and I have some other people that are interested in it. And those people that are older, maybe I would recommend doing this 13 column because you can actually do multiplication. So I'm so confused. Oh, don't be confused. So what we're doing is we're just counting on the abacus. This is an abacus. This abacus helps me count. So when we're counting, we do 1, 2, 3, 4. So that's what 4 is. How do I know? Well, just like on a die, right? If you look at a die, is that confusing? No, it's not confusing. It's just something that we're looking at, something different. So when we look at it, it's 1, 2, 3, 4. We have this. 1, 2, 3, 4. How do I know I'm counting this? I'm counting this because this is the horizontal bar. The horizontal bar is what tells me that we're counting it. That's the only thing. That's the only difference, right? So when we look at it, like if I did this, if I did that, then these are all 4s. These are all 4s, but it depends what the place value is. So here was my one example. What I do is I do 4, and this is 4, and this is 4, and this is 4, and this is 4, right? But the difference is if I say that this is my place value, if this is my ones, I have 4 here, and I have 0, 0, 4. So now I'm here. The reason why we have the dots is to show us that we're in the thousands. So this is what that means. Thank you so much for sharing my live. Yeah, see, I'm telling you, it's easy to use. was it simple to use, easy to understand. It's just when you come into the middle of a conversation, of course, you're not going to know what's going on. But when we start from the beginning, I mean, the beginning is not that difficult either, right? So it just takes some time to just see what's going on. But notice, however, I don't have any more beads to touch the 5. How do I do 5? Like, what's going on? I don't know where 5 is. Well, that is where, Alex, I was just about to talk. So, what is a 5? Well, the 5 will always be the top bead. This will always be 5, no matter what. No matter which abacus you're a part of, the top bead will always be 5. And it's really, if you can keep that in your mind, then that's what it is. So even if you talk to somebody who knows the abacus, you could just say, I know what the 5 is. It's the top bead. Some people call it the heaven beads. I don't. I just call it the top bead because it makes sense, right? It's whatever's the top. And notice that the top bead, none of these beads are touching the beam. So if they're not touching, then they're not counted. Only this one was counted. So when we do 5, and now we can go further, right? We can do 6, right? So then it becomes 9 if there's all up. Exactly. See? Easy, simple to use, easy to understand, right? So when we do it, because you know that these are 4, right? 1, 2, 3, 4. When you add the 5, we have 6. Then we have 7. And then we have 8. And then we have 9. See? Come on, Andrew knows. You know. It's just something different, right? It's just something that we're not used to seeing. And it's interesting because it's a simple way of thinking things and how everything is moving. So let's go further on and let's continue to count. The only reason why we're counting is so we can get used to seeing the numbers move. When we start understanding how the numbers move, then we can go into yes, I understand. Andrew knows something new. So we're going to continue to count. The reason why, as I was saying before, when we continue to count, we see how the numbers move. When we see the numbers move, we can start going into adding and subtracting. But there's no point of me telling you, let's do multiplication if you don't even know how to read the abacus, right? So that's why we start off understanding how to read the abacus. So let's go to 10. How do I know what 10 is? Well, 10, just like, what professional is this used for? Well, 1, teaching. 2, what it does, it solidifies math, right? So the idea is that abacus is the gateway to complex math. So when you learn how to do the abacus, it'll be easy to do other math stuff because you're compounding the knowledge of math, number skills and math fluency, and as you compound the idea of understanding how do you do the adding, subtraction, and so forth, you can expand to the other math realms, right? You could do algebra, calculus, and trigonometry, and so forth. Do they relate to all each other? I mean, that's all math, but it depends on how solid your foundation is, and that's the reason why. Nothing we knew. We have new methods. Oh, I'm sorry. I'm only 9 per place. Yes, exactly. 9 per place. So I was continuing on. So as I said before, just like how we write 10, we write 10 on the, we write 10. We remember, many people do we say, oh, this is the 10 place, this is the ones place? No, we don't. But as children, right, we teach the children these are place values. It's the same thing on the abacus. When I show 10, it's the 1 and a 0. How do I know that this is 0? Because this is where my ones place is. Division is not difficult. Actually, Lady E, division is not difficult. It's just a little bit more rules. We can get there depending on how quickly or how much the group is, how quickly the group can follow. So we can go into multiplication, division, after we learn how to do adding and subtracting. So the professions. So going back to the professions, it's the groundwork. I mean, if you really want to talk about it, it could be like accounting, right? Or it could be engineering, or it could be science, or it could be, but what it is it's building the math foundation and it's solid. So, thank you so much for following. Thank you so much for sharing my life. Okay, so that was the idea, right? So let's continue to count because I want to just continue to count. So we have 11, right? We have 11. How do I know? 1 and 1. 1 and 1. What you going to do? Okay, so we have 11, and then we have 12, we have 13, and 14. Notice that you just look at the numbers and you just read it. So sometimes if I don't know how to say the numbers like 438, right? What I'll do is I will just say the numbers. 438. So what I'll say is 438, and then I'll say, oh, it's 438. So it depends on, like, how quickly you do things. Am I quick in math? No, no. I enjoy teaching it. Am I fast in math? No. But there are those kids that do this, right? And they do abacus competitions. And with the abacus competitions, they usually do it with the Japanese abacus. There's another abacus, and I don't know if anybody knows. There's a Chinese abacus. Help as has been achieved. I tried learning abacus once. I just couldn't get with the modern tutorials. Yes, and that's the thing, right? The one thing that I noticed with the tutorials on the videos, like YouTube and stuff, they're very segregated to what they were saying, because a lot of the things, what I'm trying to do is I'm trying to relate abacus to mainstream math. And so when we start talking about it, we talk about place values. I'm not sure in the other videos they talk about place values. So that's why I like the lives, because I enjoy being able to explain and have a conversation. I've been doing abacus. I've been teaching abacus for more than 20 years. So my way, and I don't know what people see and what people don't see. So some of the questions were like, can I break a 5? No, you can't break this 5. It will always be 5 no matter what. And then the other one was like, if you put a bead like between like this in the middle, is that going to be a decimal? No. That's not going to be a decimal. The decimal only happens between the two columns. So if I have 7, right, I'm looking at it, 5, 6, 7, and then I want to do 25. So what number would that be? That would be $7.25. I'm going to say $7.25 because I think that's what everybody relates to, right? It could be anything. If I wanted to go here, I can have my decimals all the way here. So it just depends. And that was the reason why I do like going down this going through the whole TikTok live and stuff, because it's nice to have a conversation as opposed to just watching. And so I'm really liking, thank you so much for all the comments. But yeah, we'll continue on. So if we understand what our numbers are saying, if you smell what the numbers are saying, okay. So let me clear my abacus. Oh my God, I'm gonna coin that. Okay, let me tell me what these numbers are saying. There, that's my numbers. That's my smell. Okay, so this is my number. Let me know in the chat what you think this number is. What do you think this number is? Because I think this number is. And so what I would do is I would probably write it out, because, you can only see so much, right? So I'd probably write it out. If I name this my ones, my tens, my hundreds, and my thousands. My ones, my tens, my hundreds, and my thousands. What would that be? Oh, yeah, there you go. Amma? Yes. Yes, and yes, so it's 3,581. So it's 3,581. Makes sense? Because it's easy to see. But then, obviously it's because we now know how to read it. When we know how to read it, we can go further, right? So so let's do another number. Let me do another number. Let's do another number. Let's do another number. Let's do another number. Let me find a number, because, I like talking about numbers. Okay, so let's do this one. This one will be easy, right? What number do we think that is? And let me know if you have any questions. There's no dumb abacus questions. Ask me any questions you want. If you want me to start over, I'll start over. If you don't understand that this is the 5, then we'll start it. Yeah, exactly. Hi, good morning, Amma. Yes, thank you again, lady. Jojo, good job. See? Easy. Easy to understand. Simple to use, easy to understand. I got to figure that out. So again, abacus is the gateway to complex math. And so what we're doing is we're building on how to do things. How? Good morning. What? How to make it? I don't know how to make an abacus, but I know how to use it and I know how to read it. So when we do it, how is this? Well, if we're going to call this, because this is the ones, exactly. How do you use it in math? Oh, hey, good morning. Nanny, we are going to start doing adding and subtracting. So I'm going to continue on with adding and subtracting. Now, the first thing we're going to do is when, okay, so what we just did is we started understanding how to read the abacus. As we read the abacus, that's what we're doing in this book. So in the book, we're talking about how we look at things, right? This one was based for more children from 3 to 5, maybe 6, 3 to 6. And it was about practicing how to get the numbers and understand what the numbers are and the 1 to 1. So the idea was that they were supposed to trace the number and then they were supposed to find the number. Good morning. Good morning. Yes, it is a good morning. I was like doing a little bit of doom scrolling and I'm like, you know what? I think it's time to go be productive. So let's learn some math. All right. So this one is talking about from numbers 0 to 9, 5 to 9, and I just broke it up into different ways. And then it keeps going like understanding the relationship. So now what we're going to do is we're going to fast forward because we're adults and we know what the numbers are before and we know how to count backwards and we know what numbers are bigger than less than. Okay, so now we're here. We fast forward to lesson 9, and as we fast forward to lesson 9, I have broken this up to plus the 1. Now, what does that mean? What we're going to do is we're going to start adding on the abacus. When we add on the abacus, we want to make sure that our abacus is nice and clean. Why? Because in school, I noticed that we teach children to count from 1, which is fine, but in abacus, we actually teach the children to count from 0 because we would like to have a nice clean number, right? A nice clean abacus. Clean abacus, like Mr. Clean. There's a lot of things that run through my head. And the only reason why is because I'm trying to be funny. Anyways, so just like Mr. Clean, we want our clean abacus. Okay, that's not going to go very well. Okay, so what we're going to do is we're going to do 1 and 1, right? So we're going to add 1 and we're going to add 1. The reason why you want to go through the motions of 1 plus 1 because you want to see how the numbers are being added. So we could say like 2 plus 2. You could do that, not a problem, because we're adults. We know what we're looking at, right? But when the children are going through, I wanted to go a little bit slower because I want them to understand that this is not just the 1. I want to know, yeah, hi, good morning, Babel. My kids find it annoying. So going back to here, adding the 1, I want, when I have a 1 already like this, I want to show that I have another 1 and I'm only adding this 1 bead. That's the only bead. It can be this bead, it can be this bead. So the idea was to show the different scenarios of the 1. So I have 3 and I want to add 1. So now I have 4. Now we as adults, right, we're talking about, okay, this is so easy, this is whatever. Well, the reason why is to see how the beads move. So I've been watching my beads move and I can start visualizing that if I want to add 6, or I can visualize I have 5 and I want to add 2, right? So I have these two. I have 5 and I want to add 2. So when I break this up, I'm only adding the number, I broke this up to add the number. So the second add-in, the third add-in, the fourth add-in. That's what I'm worried about. In school, no, in a video that I found, I love your humor. Thank you. It's a little corny. Okay, so I was watching a video because I was trying to figure out how can I relate abacus to mainstream math? That was my goal. How do I relate to abacus to mainstream math? Because what? Abacus has been around for centuries, right? But not a lot of people know what an abacus is, and not a lot of people know how to even pronounce it. So I was like, okay, we're using a lot of manipulatives. We use this, and we're using like these little boxes and stuff, bricks, cubes, I don't know what they call them, number blocks and so forth. So we're using and inventing a lot of number blocks. We're using a lot of manipulatives. We're even drawing it out, right? So when we even talk about it to the children, we're like, okay, this is my number line. If I have my 0 here, 1, 2, 3, 4, 5, we're giving them something visual, right? We do 1, 2, 3, 4, and we start to tell them, okay, this is what we're talking about. Well, we could do that too. That's not a problem. I do introduce the number line in my books just because I wanted to show that there's a relationship. But if you really look at it, we can also use this as our abacus. We can also use the abacus as showing what we're doing. So if I did 4, right, we see 4, we can show it on the abacus that that's 4. So it's interesting that it's obvious because nobody knows what an abacus is. Not nobody, but one thing for teachers is like they have a lot that they have to memorize. They have a lot to remember. They have a lot to teach. So I didn't want it to be like abacus was this burden that they would teach. I want it to be simple. So if we can, explain like in simply, like I know some of the Abacus videos, they're like, this is what new friends are and old friends. And I'm like, what if we just use the terminology like +5, like how to make a 5 and how do you use it? Yes, scavenger, I'm getting to it. I have a story. I have stories. I have so many stories now. So again, we're talking about like doing the number line and number bonds, right? So one of the things that I was doing is I was researching on how does other people teach kids, how to add and subtract. So I was looking on this one video, and then one of the question was like 5 + 3, right? And I was like, okay, 5 + 3, and then the answer is 8, and they were really focused on the answer. They were really focused on the result. But Abacus doesn't work on the result. We work on what the add-in is. So here is my question, 5 + 3. 5 + 3. Notice it's 8. Easy, right? There's no problems. There's no nothing. We're just adding 5 + 8 because I have enough beads to add the 3. I'm sorry, 5 + 3. There's my 8. So that's fine. But then what I noticed is the focus was really focused on the result, whereas it's not the goal, right? It's the journey, just like in life. So the next question was 7 + 1. So if I go to my abacus and I add my 7, right, I'm going to add 7, and now I'm going to add my 1. When I add 1, I have my 8. Not a problem. But again, the focus is on, the common thing that I see here is that it's adding 8. Okay, let's take it one step further. They talked about 4 + 4. This is a very, this is it. This was the, oh my God, I don't know what we're doing. The reason why is because now we're talking differently in Abacus. Why? In school, we memorize what 4 + 4 is. Right? 4 + 4 is 8. We've memorized this hands down, whatever. So, and then we start building strategies behind it, right? We want 4 + 4 - 1. So doubles +1, doubles +2. We talk about that, right? We talk about 7 and we talk about 9. Well, in Abacus, we don't learn doubles. We don't, let me move this over. We don't learn doubles. What we learn is the process. What does that mean? Well, if I add my 4 just like this, I'm adding my 4. That's the top 4 that I just added right here, my 4. Now we focus in on this 4 right here. This 4 is what we worried about. Not worry. This is the 4 that we actually focus on. We focus on the process. So in school, we're actually teaching children how to make a 5. Why? Because I want to be able to use this 5. So when we make a 5, it's 4 + 1 is equal to 5, or 1 + 4 is equal to 5. This is what we're teaching the children, and that's all we're teaching. But in Abacus, we actually take it one step further. What we're going to do is we're going to isolate the variable. What variable are we going to isolate? We're going to isolate this 4. We're going to isolate this 4, so that means we're going to move this 1 to the other side of the equation. Now, am I going to tell this to the kids? No. The kids are going to memorize this formula. And the formula that they need to memorize is when I want to add the 4, I need to plus the 5 minus 1. Minus 1. That is the only thing that the kids will memorize. And my kids, the students that I have, they're 3, 4, and 5. They're not going to understand this, right? But I'm talking to adults, and I'm trying to show you how it works, in our brain. And it's like, well, why do I want to add the 4? So this is why you want to add the 4, because we want to utilize the 5. We want to utilize the 5. So here, the reason why we have the +4 and the +5 and the -1, knowing what we're trying to do. So when we say plus, we're adding. We want to say subtract, we're minusing. So when the formula, this is a formula that we have to memorize, we want to add the 5 plus 5. Notice I plus the 5 and I take away the 1. Hi, Ostrich. Welcome. Does that make sense? So now my answer is 8. And that is what makes it different. That's what makes it different from focusing on the result to focusing on the process. Does that make sense? So we're going to continue on. We're going to continue on with the 4. We're going to continue on with the 4. The reason why is because when we understand how to do it, right? I'm telling you, easy to understand, simple to use, easy to understand. So let's go back to the same one, right? It makes total sense. And that's what I'm like saying. It's like it's not difficult. The only thing is the barrier of how to read it. That's all it is. If I know how to read it, then I can do everything. So here, let's do 3, right? Again, in school we'd say 3 we learn our doubles, right? 3 plus 3 is equal to 6. 3 plus 3 is 6, and then you want to add 1. Well, you could learn it, that's not a problem. Or you could do it through the abacus. So I want to say 3 plus 4. We add our 3 to the abacus, and then we're going to plus the 4. Now my question is can I add the 4? That's the ultimate question. The ultimate questions for abacus is, can I add the 4, and how can I add the 4? How can I add the 4? Maybe that's the thing. How can I add the 4? No, there's not enough beats to add the 4, so what do I do? So here, what we want to do is we want to add the 5, take away the 1. So in this story, because my kids, the students are usually, my thought was, making of this book, my thought was that the kids are young. The students that are going through the book is 3, 4, 5, depending if they finish, depending if they finish the preschool one, right? Because in the preschool one, we talk about the adding and subtracting already. We do adding and subtracting, but we do simple, where they don't do formulas. So now we're talking about formulas, and so that's why I have these cats in a tree. The cats in the tree, there's always going to be 5 cats in the tree. When we have 5 cats in the tree, I want to grab 4 cats. So I go to the cats in the tree and I grab 4 cats. But then 1 cat runs away. So 1 cat runs away, leaving me with 7. So my answer is now 7. And that's what I've done. Okay, great. Okay, so we don't talk about strategies like doubles plus 1, doubles minus 1. We don't talk about. What we talk about is the formula. And if you talk to any other person that knows abacus, we know that this is a hands down formula. Just like we know that 2 plus 2 is 4. Oh yeah, yeah, totally, Cece. So this formula is a hands down, fundamental idea that we need to understand in abacus. No matter who you talk to, like there's that human calculator where she was calculating something with Bill Gates, and Bill Gates had a calculator. She was doing it in her head, and this is how she does it. Does that make sense? So what we're doing is we're learning the fundamentals on like how do kids do this, right? The kids do all this, and there's like this whole competition and stuff. This is what they're doing. They're doing this. They've been doing abacus for so long and hours at a time, right? I'm only on live an hour at a time, and I'm just explaining it, right? And we're going through it quickly. They would spend like weeks on understanding this part. Then they would go to the next one where they have more numbers. So if I talked about here, the numbers get bigger, right? The numbers and the questions get bigger. So what they're doing is they're going through all these questions as they go through. But for right now, we're learning the basics. You need to learn the basics. You need to understand the basics before we can go on to the more complex math. And again, abacus is a foundation. It's just foundational. And it's the gateway to complex math. And if you think about it, like when you start understanding when you understand adding the 5, making the 5 and making, adding, just simply adding, the next step would be to do the plus 10s. When you know that, you'll know everything how to do it on the abacus. So let's take it one step further. You know what? Let's take it one step further. I want to do, super simple, easy to use. Simple to use, simple to understand. No, simple to use, easy to understand. So we know the 1, right? We know the plus the 4 is equal to plus the 5 minus 1. Oh, that doesn't work well. We do that. We know that, right? We know that this is a formula. So you can take it one step further. So if I want to do 14 plus 4, right? If I want to do 14 plus 4, well, how do I do it on the abacus? Well, I do my 4 and I add another 4, right? That's my 14. But my abacus doesn't have the 5 beat. Is your abacus horizontal? That's a different abacus. So we're back to here. 14 plus 4. Now, some of the questions were like, how do you make a 10? So there's a lot of strategies in school, like how do you make a 10? You want to round up, you want to round down, you want to do some rounding, right? So if I round it, I can do this as 10, and then I have a 4 over here, and then I have a 4 here, and so forth. So there's like a bunch of strategies that happen. So let me continue on with this. So here we know what we're doing is this. Do we want to add a 4? Yes, we want to add a 4, right? To do the 4, we know all we got to do is plus the 5 minus the 1. That is all we're doing. See how we did that in the beginning? We had the 4, and then we just added 10. right? So there it is. So, Cece, if your beads are horizontal, then it's a 10 bead, and none of these formulas will work, because now what you're dealing with is you're dealing with quantity. So if I had 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what those ones are is talking about the quantity. And when you do the quantity, it's not as, it's more intuitive. You could see it, but then you have to like really count out. And so that's the difference. This one is a Japanese abacus. The one that's horizontal is the Russian abacus. And then there's a Reckenrec. A Reckenrec is the Dutch abacus, where they have the red and the green, and it's the same thing. Like, they broke it up into fives. So you could, if it's you could, like, if you really finagle it, you could break it up into 5 and 5, and you would have to like group them. So if I was talking about the 5, it would be all of this, right? So base 10 versus base 5. Whoa, nice. Okay. So yes, but you could group it like we do in abacus. I don't have a Reckonrec to explain it. But in my head, what I would do is you could group it. So if you're talking about the 5 bead, you would take the yellow or the white bead or the red bead and just group it as a whole. And you can't move it. I could tape it. But that's what I would probably do if you wanted to do it the abacus way, or look into getting a Japanese abacus, right? So yeah, it's the base 10 and the base 5. Yeah. But is it different? It is different. Just the idea, working the beads. I mean, really, what is abacus? The word abacus is just moving beads. That's all it is. And so we just happen to have only 5 beads, 1 bead on top and 4 beads on bottom. Okay, so going back to this one, like, so then we can start getting to more complex math, but notice that when I have the beads, when I have my numbers here, it's all the same, right? So just like, oh, you know what? Let's do, if I did this, 14, let's keep it with 14, right? 14 plus 4, 40. 14 plus 40. Okay, same thing. I do 14, so I'm going to do 14. I plus 1 and plus 4. Okay, now I want to add 40. Now in abacus, we don't do ones and tens. What we do is the whole number. We do the whole number. So what we're going to do is we're going to add the 4 here. Well, question, do I have enough beads to add the 4? No, I don't have enough beads to add the 4. So what do? Well, I go up back to here to my fundamental. I plus the 4 is equal to plus the 5 minus 1. So I plus the 5 and I take away the 1. And then my answer is 54. Thank you for the follow. Hey. Oh, haha, Dandelion, thank you so much for the heart. Thank you so much for the heart. So does that make sense? So it doesn't matter where the numbers are. What matters is what we're trying to do. Because we're doing just this, we understand we're only talking about the 4, not the result. We don't focus on the, 14 plus 4 is 18. We don't focus on the result. We focus on the process. So it's the journey. It's the journey, not the goal. Okay, so so that is the 5s. Now, what's next? What's after the 5s? What's after the 5s? After the 5s. After making 5, right? We made a 5. Make a 5. This is a common concept that we're teaching children. Making 5. Now, after making 5, we need to make, well, we can do minus. We got to do minus. So that's the thing that I noticed. Oh, that is a thing, right? So in school, we talk a lot about adding. We do 4 plus 1 equals 5, and then 3 plus 2 equals 5. In abacus, whatever we add, we need to subtract. So in abacus, after you learn how to make a 5, then the next one is how to do minus the 5. Why? Because, and I don't even know how you would say it. I don't think there's a thing. Anyways, so what am I trying to say? I'm trying to say is, in abacus, we do a balance. When we know we add, we have to subtract. That's something that you need to know, right? So So okay, let me take it one step back. So notice here we have a plus. Let's pretend we assume that there's a plus here. So when we write it, it's plus 4 plus 1 equals plus 5. We assume that there's a plus. Because we assume that there's a plus, doing the minus will be the same. Why are we doing minus? It's not a negative because there's no negatives on the abacus, but we do a takeaway. What does that mean? So when we do this and we do the inverse, we do the inverse, it's minus 4 minus 1 equals minus 5. Why are we doing this? Because when I want to do a takeaway, right? The question is 8 take away 4. 8 take away 4. I want to know, how do I take away this 4? So because I want to take away this 4, I have the fundamental concept of doing the 4 minus 5. Yes, and take the 5. Yes. I don't know why this was on my FYP or why I feel compelled to watch and learn abacus. I'm so excited. That's such a funny comment. Thank you so much for letting me know. Yeah, it's the strangest thing. Okay, so we're back to here. Let me focus. Focus. Okay. So when we look at this, we want to do a takeaway. And again, what we're going to do is we're going to isolate the variable. When we isolate the variable, we're going to move the 1, we're going to move it over here, just like we did it over here, right? It's the same concept. It's the same thing, right? So what we're going to do is I'm going to rewrite this equation. What I want to do is minus the 4 is equal to minus the 5 plus the 1. When I minus the 5, and I plus the 1. What am I trying to do? I'm trying to take away the 5. That's all I'm trying to do. Is it a negative? Yeah, it's a negative. But is it a negative on the abacus? No. What we're doing is we're taking away. So we're trying to show the concept of taking away. So my question is 8, right? And I want to take away 4. Well, nuts. I don't have enough beads to take away 4. But I do know that if I want to take away the 4, I can add minus the 5 and I can add the 1. Do you see that? And notice there's a number pattern that happens. There's a bead pattern that happens. So now what I do is I minus the 4, I'm going to do this. If I want to add the 4, I do this. So notice they go hand in hand. There was this one person they was talking about. It was a sentence. Oh no, that was something different. So yeah. So that's what it is. So I'm fully committed now. You know, I had a math professor, I had a math researcher said that I really sold him on the abacus because telling you it's the greatest thing next to sliced bread, and that's a very old terminology. That is how old I am. I'm very old, but I'm not. But you know what? When I learned the abacus, I wasn't a child when I learned it. I was actually an adult, and my dad was like, he went on a business trip, and the lady was like, my kid's autistic and you need to teach your kids how to do abacus because abacus is the greatest thing next to sliced bread. So he came home and he did what Chinese parents do. It's like, you're gonna learn because I said so. And I'm like, why am I learning this? This is crazy. This I don't even know what it is. I think I learned it when I was like 20 something. I was late 20s. And I'm like, I don't know what this is. What's the point of this? But now when I started going through, it's like, oh my God, I wish I'd learned this when I was a kid. But now I have 3 boys and they all learned it. Did they like it? No. But they learned it and they appreciate it afterwards. They understand that going through this made a lot of sense. And so when they were doing this, when they started doing algebra, one of my kids was like, I know algebra, but I don't know algebra. And I don't know why I know algebra. Well, and I told him the reason why you know algebra, because in abacus, we do substitution. In algebra, we do substitution. In abacus, we do isolate the variable. So in abacus, when we isolate the variable, that's what we're doing. That's what we did here, right? And what we did is we substituted. I need to find another color. We substituted this into here. Or nope, we substituted this into here. And that's what you do in abacus. I love the giant abacus. Oh yeah, thank you. That's a teacher's abacus, and that's helpful for, standing in front of the classroom and stuff. So yeah, so that was the one thing that I was trying to, and then slowly I started realizing that what we're doing in abacus is what we're doing in math. And abacus is actually not just a separate topic. It's it's math. It's just a different way of looking at things. So there's a lot of other like terminologies that's flying around, like making an array, doing number bonds. So there was this one teacher. I'm not knocking number bonds. I'm not knocking strategies. I'm just showing that we show all these other strategies, and yet we could do it on the abacus. So one of the strategies was she mentioned was number bonds. So one of the questions was I don't know. 20, we'll do, no, I'll do a different color. We'll do 23 plus, we'll do 13. We'll do something easy, right? So the number bond was this, right? And what she did was she broke it up. Can you do it for multiplication and division easily on this? Yes, you can. Multiplication, you do need to know your math facts. Let me finish my number bond and we'll go on to multiplication. So here, the way she did it was she broke it up into 20. It was a she, and there was a 3, right? She broke this up, which is fine, right? This is not a problem. And this was 10, and then this was 3. And this was a strategy she used, and it worked great for her. I'm just showing you a different way of doing things. That's all. I'm not knocking it. This is a great strategy. And it was just a way for the kids to see how to break up the number. And then what she did was she did this, and then this was 30, and then this and this was 6. And then she combined the two, then the answer was 36. That was her thing. Her thing was doing number bonds. And I'm like, okay, that's great. So let's do it for us. Let's do it for abacus. When we do it for abacus, I'm going to rewrite the question. It was 23 plus 13. Okay, so on the abacus, what I'm going to do is I'm going to add 23, right? And then on the 23, I'm going to add 13. Okay, I'm going to add the 1. So what do? We are taking this whole number, right? We're going to add the 1, and then we're going to add the 3. Well, nuts. I don't have enough beats to add the 3. Well, remember how we added the 3? We are going to use, how do we make a 5? 3 plus 2 is equal to 5. So what are we going to do? We're going to isolate this variable. This is the one I want. Remember that what we did is we took it over to the other side. So when I rewrite this question, rewrite the formula, it's plus 3 is equal to plus 3 is equal to plus 5 minus 2. So again, I will plus the 5 and I take away the 2. And then my answer is 36. So, okay. So, the multiplication question. Multiplication. I wonder if NCMS is here. Hi, Keish. Thank you so much for the hearts. Sometimes it's hard to like look up and stuff. Okay, so multiplication. In Abacus, we actually do not memorize 12 times table. Why? Because it is redundant. Why is it redundant? Okay, so one of the things is like one thing for Abacus is you need to know your math facts. That's the one thing. You could do it like additive cumulative addition, right? Like 5 plus 5 plus 5 plus 5 plus 5. That you could do that. And that's what I did with my children because I wanted them to I wanted to push them into memorizing the multiplication facts. Now, why do we need to get them to do that? Because when the questions get bigger, how do you do the 2 beads on the okay, you know what? We'll do that. Let me talk about this really quickly because it will be easy peasy. So this is the Chinese abacus, and the Chinese abacus works roughly the same as the Japanese abacus, but it's a little redundant. So in the Chinese abacus, we is still the bottom bead, right? All the bottom beads has a value of 1. The Japanese abacus has a value of 1 too. So this is 1 and 1. So if we do 2, and I'm going to skip. This is 4. That's 4. Now we do 5. Well, I can do 5 here. Japanese abacus, 5's up here, but this is 5 and this is 5. So now my brain on the Chinese abacus needs to remember there's 2 ways to do 5. And I'm like, I don't know. That's too much energy. But whatever. So, if you end off at 5, it's fine. But then if you do 6, 6 is still the same. 6 is this. 5, 6. This is 6. 5, 6. 7, 8, 9. 7, 8, 9. Not a problem. Now we go to 10. Japanese abacus makes sense because this is when we start doing place values. Chinese abacus to me doesn't make sense. Why? Because now we're at 10, but I use this as the ones column. So why am I here? I should be here. Or here's another way to do a 10. That. When you do this as a 10, that kind of confuses me. Like, how do I know? How do I know? Because this is 5, this has a value of 5, and this has a value of 5. So 5 plus 5 is 10. Right? So 5 plus 5 is 10. This is 10, this is 10, or this is 10. Now this makes sense because now we're using the place values like we're supposed to, right? Because we're using the place values, it's easier to visualize. So, and that's how you use it. So then when we start doing this, right, let's do 23 plus 3. So we have 23 plus 3. Plus 1 and then plus 3. Well, I don't have enough beads to add the 3, so what do? I got it plus the 5 minus the 2. So I still need to plus the 5 minus the 2. And my answer is 36. You could, if you did have the Chinese abacus, just ignore the top bead and the bottom bead, the most top bead and the most bottom beads. You could do that too. Okay, so now we're going to go back to multiplication. So again, multiplication, I'm going to do, like, we don't learn our 12 times table. Why? Because if I do 12 times 6, right, what we're going to do first is we're going to know where our starting point is. As we know our starting point, why do we need to know our starting point? Because we want to know where to put our answer. Whoa, wow, the Japanese one makes more sense. Yeah, right? The Japanese made everything more efficient. And because they can do it, they've done such a wonderful job. It's such a fantastic job. Like, there's nothing to it. Like, it's really quite amazing. But there is no competitions for Chinese abacus, but there's a competition for Japanese abacus, which is really quite interesting. And why? Because when I start looking at 10, there's 3 ways to look at 10. And then that's what kind of muffles the mind a little bit, right? That's like, it gives me a hiccup. Whereas on the Japanese abacus, you always know that this will be 10 no matter what. Okay, so we're back to here. Now, the reason why I want to know is where I'm going to put my number. Where am I going to put my answer? So I'm going to put 1, 2, 3. How do I know? Because I'm going to count my digits. I have 3 digits. I'm going to go to the hundreds column. 1, 2, 3. So then when I work it out, 6 times 1 is equal to 6. 6 times 1 is equal to 6. 6 is a single digit. If I have a leading 0, like this, notice it says 0, 6. So if I do, like, if it's 2 digit, I know I'm going to move my finger to the column, right? I move my finger back and I'm going to add 6. Make sense? So now my next one, so I've done the 1, so now I'm going to do, so I'm sorry, I forgot my arrows. So now I finished the 1, now I'm going to do the 2. 6 times 2 is equal to 12. So 12 is a double digit. All I got to do is add 12. 1 and then 2. And then that's it. That is all I need to do for my double digits, especially for my 12s. So I don't need to memorize my 12 times table because I do it on the abacus. We're going to do it again. Now, so now the difference is, let's do it the way the mainstream math is. Mainstream math, they do 12 times 6. Same thing. In the mainstream math, we do ones first, and then we do the tens, right? So when we do it that way, we do the ones first. So I'll start here, and I do 12, right? 2 times 6 is 12. But notice my finger is here. Because my finger is here, that means I got to go 1 forward, add my 12, and then I got to go back. Because that's where I ended off. But now I do 6. I have to remember to go forward and then add my 6. So I'm going to add 6. And then my answer is 72. Now, this is fine because it's only 2 digits. But it gets a little hairy when it's like more than 2. So if we do 12, 7, 8 times that by 63. This is a common abacus question. Right? And it's the same. Like, we could do it this way, but then it gets really hairy because now you're You're going against the order. So we can do this, not a problem on the abacus. What's the first thing we do? Well, the first thing we need to do is we need to understand where our starting point is. 1, 2, 3, 4, 5, 6. If it's too much, let me know. I can go back down a little bit. So we have 6. 1, 2, 3, 4, 5. Okay, we cannot use this abacus. We got to use the big abacus. This is why 13 is good. 13 is good because then you have a lot more columns. Okay. So we're going to do this one. This is the question that we're working on. Now, we figured out where our starting point is. Our starting point is at the 6. 1, 2, 3, 4, 5, 6. We're at the 100,000s. How do I know? Because this is my thousands, this is my ones. And then I'm going to start working it out. I'm going to keep my finger here just so we can keep track, right? Because it's a lot of numbers. So we do 6 times 1, right? 6 times 1 is 6. 6 times 1 is 6. Again, 6 is a single digit. I go back one column, right? I move my finger to one column, and I add 6. 6 times 2. 6 times 2 is 12. So I add 1. I move my finger, and I add 2. 6 times 7. 6 times 7 is 42. I add 4. Remember how to add the 4? There's not enough beats to add the 4. This is why it's best to understand your fundamentals, right? So when I want to add the 4, it's plus the 4 is equal to plus the 5 minus 3. Because I'm at, no, 1. Sorry, 1. So that's what we're trying to do, right? We're trying to add the 1. We're trying to add the 4 because right here. So I want to add the 5 minus the 1. And then I go here and I add the 2. So I'm going to add the 2. So we're at 7. We finished the 7. Now we're at 8. Notice it gets complicated really quick. So that's why you have these numbers and then you do the order correctly. You do the order. You do the order forward. So now 6 times 8. 6 times 8 is 48. So I want to add the 4. Again, I don't have enough beats to add the 4. So what I do, I plus the 5 minus the 1. I know this because I've remembered it from before. And then here I add the 8. Okay, which is fine. We're done with this. Now what we need to do is we need to reassess. We're going to reassess where our starting point is. Why? Because we don't need to worry about this one anymore. And now we're stacking it, right? We're stacking our numbers. So just like as we did it here, we would have to do it here. So here is our 3. So 1, 2, 3, 4, 5. So I have to start at the 5 column. 1, 2, 3, 4, 5. So I'm over here. I'm at the 10,000s. So when I look at it, 3 times 1 is equal to 3. 3 is a single digit, so I go back one column, right? And I add 3. And that's what I did. I'm adding 3. So the next one is 3 times 2. 3 times 2 is 6. 6 is a single digit as well. Oh, this is going to get complicated. All right. Why is it going to get complicated? Because now we're adding and subtracting. We're now adding more than just 6. Why? Because now what we're doing is we're going to start talking about two-step equation. And I didn't talk about two-step equation. That's why when I do multiplication, it kind of gets a little hairy because I don't have the questions. Sometimes I just make up some numbers. I can do it. Hopefully everyone can understand. So what we're going to do is we're going to add the 6. There's not enough beats to add the 6. What do? We would talk about 6 is equal to make a 10. Plus the 6 is equal to plus the 10 minus 4. I want to minus the 4. I don't have enough beats to minus the 4. All right. I need to plus the 10. I don't have enough beats to plus the 10 because the 10 is over here. What's another way to add a 10? We know that 1 plus... It gets complicated quick if you don't know the basics. But that's why we slowly go through it, right? So I want to add the 10 minus the 9. So I add the 10 minus the 9 and then add the 4. I want to minus the 4. How do I minus the 4? Minus the 5 plus the 1. Yeah, we can talk about that in a little bit if that got confusing. But it's a two-step equation. And but then it go, yeah. 6. So we did 6. So 3 times 7 is 21. I add 2 and I add 1. And then 3 times 8 is 24. So I add my 2. There's not enough beads to add 2. So how do I add my 2? I make a 10. Plus the 2 is equal to plus the 10 minus 8. So I plus the 10 minus the 8. I plus the 10. There's not enough beads to add the 1 here. So what do? I plus the 1 is equal to plus the 5 minus 4. So I plus the 5 minus 4. And then over here, I minus the 9, right? Because I wanted to add the 1. And then I wanted to add minus the 8. Brr, minus the 8. I'm over here. I got carried away. And then I want to plus the 4. So I plus the 4 over here. Hopefully that's correct. I got confused right around here. Because I worry about the two-step problems. The two-step problems is what kind of, presenting and doing two-step. When you do it, you take it slow. But, again, this is like the beginning part where we're trying to understand everything. So that's what we do on multiplication. So my answer is, who can tell me what my answer is? What's my answer? Who can tell me what my answer is? And I don't know if. Whew, that was a big one. I should be more prepared with my multiplication. Yeah. Let's see. Drift says 80,514. Yes, exactly. I followed up to the point where I think I need the fundamentals first. Yes, exactly. Can I do a simpler one so I don't understand the moving over? The simpler one in multiplication or the simpler one in adding and subtracting? Yeah, the biggest thing is knowing the fundamentals. But because I've been teaching abacus for so long, I kind of know, but I still get messed up, between the double digits in multiplication. Okay, so multiplication. Do you want two? Okay, we can do two digits times 2 digits. That would be the easiest. I'm using my kids' old notebooks because sometimes they don't use it all. All right, so let's do this one. Yeah, this one would be easier one. Yeah, because I wanted to. The reason why was because I wanted to explain it gets complicated quick if you do it the other way, right? What I mean, if you do it this way and you had this many numbers, and that was the example. And I guess I should have stopped there, but I was like, I wonder how this looks. Let me go. I'm just looking for a question. Okay, this one would be good. All right. So the question is 81 times 2. Yeah. So we don't need an example, but abacus can be used for complex math. Abacus is the gateway to complex math. So you get the foundation, you understand how the beads move, and then you have a structure to critically analyze the framework, and that will help you go into other things. It doesn't go hand in hand. Like it doesn't go hand in hand like how to find an x or so forth, or even calculus. Like calculus is its own separate topic. So what it does is abacus lays the framework, the foundation of understanding how to add and subtract. And as you know that, and as that becomes more solid, then you can build on top of it. So you're not hung up on adding and subtracting or multiplication division. That's why. So abacus is actually just the gateway to complex math. It provides it because now you don't have to think about because it's more automatic. You don't have to use your working memory to figure out the more complex questions like calculus provides. This would become more part of your long-term memory and become more innate. Okay, so the question is this. So here I'm going to go back to my colorful abacus, and I need to find my that was the one thing is like I was like, oh, abacus is so great, it can be everywhere. It's like no. Abacus is a phase in the realm of things, right? It's a stage. And just like when we add and subtract, after we know what you have to add, we can go into multiplication. Is it the same? No, it's not the same, but we build on it. So it activates multiple senses, so it roots itself deep in memory. Yes, exactly. Just like the muscle memory in your fingers. So that's why when you work through the abacus, you have muscle memory how to move the beads. And that's the reason why we do the simpler numbers, even though it's easy for us as adults and And the kids will be like, this is so easy, whatever, I don't care. But if you go through and just say, okay, just follow the process, you're going to start seeing it. And so that's the one thing. Can you use 7 times? No, you would have to memorize. You would have to memorize 7 times 6. The way I would tell the kids, if you want 7 times 6, we would have to do 7 plus 7 plus 7 plus 7 plus 7 plus 7. 1, 2, 3, 4, 5, 6, 7. Or we would do 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6. We could do that. That would be on the abacus. But if you're looking at it here, it wouldn't work. We would have to memorize our math facts. So if we did this, this is the combination of the plus tens and the two-step equations. Why? Because 7 and 6, they're kind of there's a little bit more into it. But the two-step equation is just combining the 5s and the 10s. So it's kind of stuff that you already know. So here's the question is, let's talk about where are we going to put our answer. 1, 2, 3. We know we're going to do 3. So we have 1, 2, 3. So the question now, we're at the hundreds. And at the hundreds, we're going to figure out 2 times 8 is equal to 16. So all we got to do is add 1 and add 6. And then 2 times 1 is equal to 2. 2 is a single digit. Because it's a single digit, we want to go back one column. And I move my finger here and I add the 2. And that's it. So that's multiplication, at its as its root. But then, when we start adding in all of the other things that we need to do, that's when we start understanding like the more complicated stuff. So we can go into the two-step equation. So here, what is a two-step equation? We know it. We just don't know it. So we do 6. Okay, so we're at this one. And sometimes it's nice to have a running total so you can keep track of stuff, because it gets a little monotonous after a while because there's so many numbers, right? So we have 6. We want to add another 6. So this is the 6 we want to add. But notice I don't have enough beats to add the 6. So what do? I need to plus the 10 minus 4, because that's how we make a 10. So I'm going to plus the 10, or remember, plus the 10 just means going over to the next column. And I want to add the 4, minus the 4. I can't minus the 4. This is the two-step equation. Hi, Karen. This is the two-step equation. What does that mean? Well, now I did a 10 and I need to minus the 4. Minus the 4 is minus the 5 plus the 1. So I minus the 5 plus the 1. So that's what I did here. So my answer is 12. Now I go to the next one. I do 6. Right? Is there enough beat to add 6? Yes. So all I got to do is add the 6. So that's 3. And the thing is as the kids go through it, I had my kids do it this way, and then they got tired and like, you know what? I'm just going to memorize it. So it could be just one thing that they do. So now the next one number is this one, right? We're at the 4. Is there enough beats to plus the 4? No, there's not. So I'm sorry, plus the 6. What do? Plus the 6 is equal plus the 10 minus 4. So I want to plus the 10, and I take away the 4. Again, I cannot take away the 4, so what do? I need to minus the 4 is equal to minus the 5 plus the 1. So I minus the 5 and I add the 1. Okay, so now we finish with this one. We're going to the next one, which is this one, right? So now, what do? I want to do? I want to add the 6. Plus the 6 is equal to plus the 10 minus 4. See how it's repetitive, right? But it solidifies what we're trying to remember. So we want to plus the 10, and is there enough beats to take away the 4? Yes, there is. So what do? We minus the 4. And so my answer is 30. And then we're here, right? Is there enough beats to add the 6? Yes. How many have we done that? 1, 2, 3, 4, 5, 6. So we're just adding a 6. So my answer is 7. My answer is 36, and my final answer is here, right? Is there enough beats to plus the 6? No. So what do? Plus the 6 is equal to plus the 10 minus 4. So I plus the 10, and I take away the 4. Is there enough to take away the 4? No. So what do? I need to minus the 4 is equal to minus the 5 plus the 1. And then I minus the 5 and plus the 1. So then my final answer is 42. So you could do cumulative addition. It's the same thing here, just, different numbers. Yeah. Wow, that was already an hour. Woo! Anybody have any questions? We can continue on with multiplication. If we want, we could do multiplication. We could do another one. We could do 2. Let's see if I can find a two-digit. 2 times 2. Let's see. No, we could do 3. You want to do 3? We could do 3. Or we do 2. I think 2 would be, well, we could do 3. Let's do 3. What do I mean by 3? This one. 6, 7, 9 times that by 2. So again, what are we going to do? We got to find our starting point. I'm wrapping my brain around multiplication. Yeah. How do you do division, or is it too complicated? We can do simple do simple division. Let me go find my question. Let me finish this one multiplication. This one would be easy. Why? Because we already know the basics. So we have 1, 2, 3, 4. Again, we find our starting point. So we do 1, 2, 3, 4. I'm at the thousands. I don't know if I like this color. Okay, so we do our thousands, right? 1, 2, 3, 4. And I say 4 just because I don't want to say ones, tens, hundreds, thousands. It's a little much. Compose everything that we do to figure out how to make it as simple as possible. So here we do 2 times 6. 2 times 6 is 12. So I add my 1 and I add my 2. No problem. 7 times 2. Oh, I should do it the other way. 7 times 2 is 14. I add my 1. I add my 4. I'm going to have to pause for a little bit. Excuse me. Okay, I think my coughing fit's done. So if we did this, let me finish this. So I'm going to add 18. I plus the 1 plus the 4. There's not enough beats to plus the 4. Sorry, there's not enough beats to plus the 1. Plus 1 is plus the 5 minus 4. So plus the 5 minus 4. And then I add my 8. Okay. The question is, you were doing tens and the ones in the first column, but not now. Sorry, I'm thinking. Okay. This would be the ones in the first column. How do I know? Are we talking about where do I put the dot? Where am I putting my ones? Is that what we're talking about? Because on the other abacus, I just chose a dot, if that's what we were talking about. Earlier, when you were doing addition and you had columns on the abacus. Yeah. So, here, if it's the Chinese abacus, there's no indicator. But on the Japanese abacus, there's an indicator. And you could choose any dot, if that makes sense. So if I wanted to, I can have this as my ones, because I just have a dot here. Or I could use this one as my ones. That's fine. The reason why I want to use the dot, because it's an indicator that this would be my ones. You could do this one, you could be right here, but then it gets kind of confusing because as you add more numbers, I would forget where I started, if that makes sense. So here, there's a dot here, that's why I would be able to use it here. And so using the dots is only to use as an indicator. So you have to know which dot you have chosen. Yes, exactly. You have to know which dot you chose. Because, yeah, because you get confused. I mean, just like as we did like these questions, right? They get long and they get kind of mind numbing. And then if you happen to forget where your numbers are, where you happen to forget where your number is, you'll be like, ah, nuts, I'd have to do it again. And sometimes the questions get really big. Why do you start at the hundreds when you in the row when you multiply? The reason why, like here, for here, why do you start on the hundreds row when you multiply? It doesn't matter where I start, it's how many digits I have in my question. That's why. And the reason why, the one reason I start in the hundreds is because I have that many digits. So this one I have 4 digits, I would start in the thousands. If I had another set, right? If I did 81 times 24, then I would start at the thousands because I have 4 digits. 1, 2, 3, 4. So when we look at our question, in Abacus we have a conversation. We want to know what we're trying to do. So here I would start at the thousands because I have 4 digits. And if I had one more digit here, then I'd start at the 10,000s. So some of the reason, so going back to the question, the reason why is because my digits are 3, and most of the, and when we start doing it, like you can't start at the tens because then you're just doing math facts. Does that make sense? Yeah. So yeah, the dots are specific. Okay, so we can do more multiplication. If you want me to do that, well, let me see if I can find another one. We could do division. Let's do some division. Division's a little bit more different thinking. But you know what? It does align a little bit better with mainstream math. Let's see if I can find a blank paper. I don't have any more blank paper. All right, let's do this. Hold on. Hold, please. Okay. You know what? I'm going to do this. All right. Okay. Because I've got 3 boys and they all have like random notebooks that they haven't finished. Okay. So. Okay. Division. Division's a little bit, but it is possible. Oh, keep going with the one you were doing. Oh, okay. Sorry. We'll go back. So again, we're going to find our starting point. Excuse me. So again, we do how many digits, right? We have 1, 2, 3, 4. So we're going to start at the thousands. 1, 2, 3, 4. So I'm going to put my finger here. I always tell the kids, no matter what, I always say it. The reason why is so we can keep track. Because there's a lot of numbers that fly, right? Remember when your x, you add the number 0 for the next number in the, yes. So why would I do that? Because when I have a single digit, I want to make a single digit a double digit. So there's a leading 0. It was just one of those things like trying to figure out how to remind everybody to go one column back. That's the reason why. So like 2 times 1 is equal to 2. So notice that there is a leading 0. So you would pretend that there's a 0. So you know that this is a 0 and then this is a 2. That would be the reason why. So that's why I did that. Because it was just one of those things like sometimes we think in double digits and sometimes we think in single digits. But in single digits, you need to remember to go back one column. Okay. So the question is, we're going to start here. 1, 2, 3, 4. So 1, 2, 3, 4. I'm over here. The question is 2 times 8 is equal to 16. I almost had a brain fart. Okay, so I'm going to add the 1 and I'm going to add the 6. Again, notice when I add 1, there's my 1, and I'm going to move my finger, there's my 6. So then the next one is, so I did this, now I do this. 1 times 2, 2 times 1 is 2. 2 times 1 is 2. 2, just as I did here, is a single digit. What I want to do is I want to go back one column. So if I'm here, I'm going to go back one column, I'm going to add 2. So now, I'm done with 2. See ya! Wouldn't want to be ya! So I'm done with 2. So the next thing I want to do now is I want to figure out what my next starting point is. So I have 1, 2, 3. So I don't need to put my finger here anymore because I just redid it. All I need to do is I need to redo where my starting point is. So I do 1, 2, 3. Whoa, I need to go soon. Um, yeah. So the question is 4 times 8 is equal to 32. So I add my 3 and I add my 2. I add 30 and then I add 2. And then 4 times 1 is 4. 4 is a single digit, so I go back one column and I add 4. So then my answer is, what's my answer? Anybody let me know what my answer is? Um, 1,944. Yes, exactly. Right? Yes, thank you, Dandelion. Is it? I'm not gonna. I'm just trying to figure out. But yeah. Yeah. So it makes sense. So I mean, we take it slow, obviously, but it was one of those things like that we understand. So I know we brushed through a lot of the adding and subtraction, but there are still a lot of fundamental adding and subtracting that needs to happen before we get to this point. So we start off. So the kids, when they go through it, they need to know their all the way to their plus tens. That means they need to know how to make their tens. So when they know how to make their tens and they know how to take away their tens, then you can slowly go into their multiplication. And as you go to slowly multiplication, they need to learn and memorize their multiplication fact. That's just one of the things. We in Abacus we don't focus on the multiplication fact, but we solidify it with the other way. When you go into more multiplication on the abacus, we solidify our math facts. So in school, I don't feel like in school we don't do more numbers, right? In abacus, we do a lot of these numbers, so it gets really solid. So does my kids have problem with it? No. Sometimes my other kid has a brain fart, but that's just the way he is. All right. Anybody have any other questions? Whew, goodness, I haven't learned this much in 13 years. Yeah, right? Like, it was like one of those things, like, but you know what? It was easy, right? It's easy to understand. And it was easy, like, because now we're just kind of, you know what it was? It was like filling in some of the gaps. And when I was going through Abacus, I'm like, oh my goodness, now we're just kind of filling in the holes and the gaps that we have. And so when we start talking about like making a 5, making a 10, it was really quite interesting. But yeah, when I was doing my research on like the different numbers and stuff, how do other people teach math, and how does it relate to mainstream math? So, can you do 3 digit times 3 digits? Sure can. Let me see if I can find a number. Um. Uh, okay, so this will be my last one, and I'm gonna head out because my kid is running. He's in track, and I gotta drive. I gotta drive somewhere, man. Trying to find my question. Let me see if I can find a question. Oh, I guess it's not here. Okay, we'll do this. Okay, I'm gonna do this one. So we'll do uh 295 times 273. Okay, same thing, right? We have six digits. That's why I gotta go here. Okay, 6 digits. 6 digits. 1, 2, 3, 4, 5, 6, right? Because we know 3 and 3. 3 and 3. What you gonna do? So we have 1, 2, 3, 4, 5, 6. So we're over here at the thousands, 10,000s. No, 100,000s. We're at the 100,000s. So because we're counting our digits, so we know where we put our answer. So the next thing we're going to do is we're going to do this first. And then we're going to do this. And then we're going to do this. That's the path that we're going to go. Hey, it'll be fine. It'll be fine. It's simple. Simple to use, easy to understand. So 2 times 2 is equal to 4. Okay. Then 4 is a single digit. I go back one column and I add the 4. 2 times 9 is 18. I add my 1 I add my 8. I add my 1. Remember, what do we do when we plus the 1? Do I have enough? No. Plus the 1 is equal to plus 5 minus 4. So plus the 5 minus the 4. We already know that. Not a problem. And then we add 8 because we're at 18. The next one is 2 times 5 is equal to 10. 10. I just need to add the 1. Not a problem. And there's my 0. Okay, we are done with the 2. See ya. Wouldn't want to be ya. But we are. Anyways, now we got to recount. We got to reassess our starting point. What does that mean? So we have 2 here because we've already finished the 2. So we have 2 here plus 3. 2 plus 3 is 5. So I'm going to start at the 5th column. 1, 2, 3, 4, 5. Now I'm going to be here. I'm going to do 7 times 2. 7 times 2 is 14. So I add my 1 and then I add my 4. I add my 1, which is 10. I add my 4. 4. Can I add a 4? No, I cannot. What do? I need to plus the 4 is equal to plus the 10 minus 6 because we're making a 10 here, right? So we're going to plus the 10. Remember, when we add the 10, we go to the next column and then we take away the 6. So we're done with this 14. We're done with this 4. And my finger is still here. I'm not moving it because we add the 1 and we add the 4, right? The next one is 7 times 9. 7 times 9 is 63. I feel like I need to move it up. Okay, 7 times 9 is 63. I add 6 and then I add 3. Is there enough to add the 6? Heck yeah, there's enough to add the 6. I don't need to do any thinking. And then I add the 3. I add the 3 here. My next one is 7 times 5. 7 times 5 is 35. All right. Some thinking here, but we know it, right? What do? Plus 3. Is there enough? No. Plus 3 is equal to plus the 5 minus 2. So I plus the 5 and I take away the 2. So I did my 3. Now I need to add the 5. And I'm done with that. Okay, so I'm done with that, right? Thank you for the hearts. Okay, I'm going to cross that out. I'm going to cross out I'm going to cross out the 7. I'm going to move my finger because now we're going to reassess again. So tell me in the comments, my reassess, where am I going to start my third number? Right? We know the pattern. There's a pattern to it. Where am I going to start my third number? I'm going to use a different color. I'm going to use green. I need green. Exactly, 4. How did you find 4? Right? Yes, the 4th. Right? So I'm going to use green. We're going to do 3. 1, 2, 3, 4. Exactly, right? So I'm going to count it again. 1, 2, 3, 4. So I'm at the thousands column. So the question is, okay, it's going to get a little complicated. Why? Because 3 times 2 is equal to 6. 6 is a single digit. I go back 1 column. Now I need to add 6 here. Remember, there's not enough beats to add the 6, so what do? Plus 6 is equal to plus the 10 minus 4. When we plus the 10, we take away the 4. So I'm going to plus the 10 over here, and I take away the 4. But notice, plus the 10, take away the 4. When I do it, I always use my fingers to remind me what I'm trying to do. Plus the 10, take away the 4. Plus the 10. Not enough to plus the 10. So what do? Plus 1 is equal to plus the 10 again and minus the 9. So I plus the 10 minus the 9 minus the 4. So what I do with the kids is I usually chant it out again. So I plus the 10. So I'm going to add my 10, take away the 9, and then take away the 4. There's not enough beats to take away the 4. I want to take away the 4. I can't take away 4 because there's not enough beats. So what do? Minus the 4 is minus the 5. Minus the 5 plus the 1. So I minus the 5 and I plus the 1. And I'm done. 1 and done. Okay. So now what am I going to do? I already did the 2, so now I got to do the 9, right? So 3 times 9 is 27. So I add 20 and I add 7. I add 2 and then I add 7. Is there enough beats to plus the 7? No. 7 is equal to plus the 10 minus 3. So again, I have to plus the 10 minus the 3. Plus the 10 minus the 3. Plus the 10. Is there enough? No. Plus the 1 is equal to plus the 5 minus 4. So I plus the 5 minus 4 and then minus 3. So I'm minus 3 here. Can I minus 3? No. Minus 3 is equal to minus the 5 plus the 2. So what I do, minus the 5 plus the 2. I stay here because that's my last number that I put in. My last one is 3 times 5. 3 times 5 is 15. Oh, that's easy. That's no brain work there. Because there's 1 and then there's 5. And that's my answer. Okay, in the comment, can we read the answer? Oh, that was fast. 8, 0, 5, 3, 4. Yes, exactly. Exactly. So it makes sense? Oh, I should write it down. 8, 0, 5, 3, 5. Abacus made me love multiplying numbers. Oh, that's funny. That's so funny. Yeah. I mean, it makes it easy. It makes it easy, but you get lost in the numbers because there's a lot of numbers that fly around. But that's why you have to really be solid in your foundation. When you're solid in your foundation, moving the numbers would be really quick. So, but because we don't know it solid, I mean, I kind of brushed through a lot of it. There's a lot more to adding than just adding. It's different because in regular mainstream math, they're just like, just add, you'll be done. But in Abacus, there's actually a methodology. There's a system. No, not a system. Excuse me, take that back. There's a pattern. There's a pattern to adding. And on the Abacus it shows. And so that's what I'm talking about with the chart. So here's a little table that I created because I was like, there's reasons why we do certain things. And when you look at it, we have like, this is the simple, right? What is simple? So we do 2 plus 2. Easy, right? There's no formulas involved. And then there's this one, which is there's formulas involved because we have the 3. Is there enough to add the 3? So here I have 4 plus 3. Is there enough? No. So what do? I have the 5. So now we're making a 5. So then we have this, and again, as I said before, this is the tens. This is making the 10. So if you notice, if I go down this path of adding the 3, now I have to remember that when I add the 3, I have to either add the 10, make a 10, or make a 5. But those are the only things you need to do. Now, and so that was the things like knowing where you are and what you're trying to do. You don't need to memorize the table. You need to understand, do I have enough and how do I do it? That's the fundamental is, how do I do it? Do I have enough? How do I do it? If you can answer those questions, then you can fit all of the equations, all the formulas that we've just learned anywhere. But it goes back to, how do I do it? Do I have enough? How do I do it? All right. Okay. So is there any lasting questions for me? If not, it actually helped me math more since I struggle a lot back and then doing 2 digits plus 2 digits. Yeah, doing the 2 digits, it's really quite interesting because when we do the 2 digits and stuff, we go as a number as a whole and not like single. So like when we do this, right? We would if we were to add these ones, we do it as a whole. So it'd be 14 plus 63 plus 35. Yeah. Okay. So any last minute questions? Are 5s and 10s? Yes. Yes. That was the thing that kind of blew me away. 5s and 10s are the only way. Now the reason why? Because if you notice, what we did, like when we want to plus the 10, okay, let me. Yeah. Okay, yes. To answer your question, the basic is yes. You only need to know the 10s, you only need to know the 5s. Why? Because, okay, so let's say we have the number 49. 49 plus 2. 49 plus 2. Okay, I'm going to have my 4, I add my 9. I want to plus the 2. Okay, plus the 2 is what? There's not enough. So we have to, plus the 2 is equal to plus the 10 minus 8, right? We know this because we're just adding an 8. So we're going to plus the 10 minus the 8 plus the 10. I don't have enough beads to plus the 10. What's another way? The other way to plus the 10, right, is plus the 1. Well, plus the 1 is equal to plus the 5 minus 4. So all I got to do is plus the 10 minus the 4. See, that's the two-step equation, and that's it. That's all you need to know. That's it. It depends. It gets more complicated, right? Because if you had 9, like 999, right? So it's actually kind of easy if you think about it, right? Yeah, basically you only need to know the multiplications, the tens, and the fives. Yeah, exactly. So, well, division's a little more. But no, so here's the question. 999, let's say plus, we'll just do plus 2, right? Easy. We want to plus the 2. We know we need to take away the 8, right? We take away the 8 just to get it out of the way. But then we need to plus the 1, right? Because we need to plus the 1. There's not enough to plus the 1. What do? We need to plus the 1 again. Minus the 9. So I'm going to minus the 9 and plus the 1. Not enough beats to plus the 1. What do? Plus the 10 minus the 1. So I plus the 10 and then minus the 9. Sorry, I misspoke. But that was the thing. So a lot of it is just picking it back onto what we're trying to do. It just depends what we're trying to do and how we're trying to do it. So we have to just keep track of stuff. But yeah, you only need to know your 5s and your 10s for adding and subtracting. Multiplication is to know your multiplication facts. And then division, there's a little bit more rules. But I won't go into that at the moment. But yeah, I hope that answered your question, Dandelion. But yeah, the solid of the 5s, the 10s, 5s and 10s. It's the adding of the 5s and taking away the 5s. It's adding of the 10s and taking away the 10s. Yeah, so I don't get confused about the rows. Yeah. So remember, that's why when we call it out, we don't say plus the hundreds minus the 80s, because then it's just too complicated, right? What we did is we just boiled down to what are we trying to do. Adding a 10 is only going to the next column over. That's all we're trying to do. So when we add a 10, all we're trying to do is go to the next column over. We want to take away the 10, we only want to take away from the next column. So the 10, so when we do the minus, right? Minus 2 is equal to minus the 10 plus the 8. When we do this, we're only taking away from that one column. That's the only thing we're doing. We're only taking away from here. So if I do 18, take away 20. Let's do 20. Take 20, take away 2. So the question is 20, take away 2, right? So I want to take away the 2 from here. I want to take away the 2. How do I do it? I have to take away the 10, which means minus the 10 plus the 8. Minus the 10 and then plus the 8. So the 10, the concept of 10 is only the column next to it. That's it. It doesn't even matter. It doesn't matter where you are. It's always the next column over. You're never going to get minus the 2 is equal to minus 1,000 plus 4,000 or 800. You never get that. You always get the fundamental, can I get rid of all that stuff? It's always going to be minus the 2 is equal to minus the 10 plus the 8. Always. Yeah. Wow, we still have 6 people in the room. I find it amazing. I find it amazing because I've been dealing with, with the kids and stuff, and I don't really have conversations and discussions. And I really enjoy, having discussions and trying to think, how do we connect everything and how it all connects. So, but I do appreciate all the comments and all the compliments. Thank you so much. But I am going to head out. I'm going to go see my kid run. But if there's any last minute questions, let me know. Thank you again. Oh, thank you again for the dolphin. Wow. Thank you so much. Whew. Oh, I appreciate it. I appreciate all the gifts and all the comments. I do appreciate the comments and the discussion, because it's always the discussion that makes me just appreciate how simple it is, simple to use and easy to understand. thank you for your random lesson. I was looking for that was the other thing. Like I was on last night and yeah, Alma was on and Dandelion was on last night and I was like, yeah, 3 a.m, right? Like I'm like, who would want to learn abacus in the middle of the night? And I'm like, you know what? I'm just gonna see who's there, and if anybody wants a show, that's great. But if it's not, that's fine because when we are in the middle of the night, we just want to go to sleep because our brain's tired. So I do appreciate the times that we all are together and we have a conversation. So yes, I do appreciate it. And Ethan, go to sleep. Good night, everybody. Good night. It's morning for me. It's still morning. I'm gonna head out. I gotta go. I'm gonna go. But I will be on live again. And just follow me, and I'll go live, and we'll talk more about abacus and how great it is next to sliced bread. Thank you, Alma. Thank you so much for all your help. I do appreciate it. And I don't know how to say Voth. I'm thinking Voth. I'm thinking the K is silent. When? I'm not sure. It depends on. But go ahead and follow me and get notified. Basically, the nice aunt from the family. I try to be. I try to kid around a lot. The E is silent. Koth. But is the K silent? Oh, you're welcome, Dandelion. The K. I do want to know how to pronounce this. Koth. Koth. No. The V. Voth. Have a good night, Lady E. Ugh. Okay. I will have to think. Bungo. Bingo. Oh. Kavoth. Kavoth? Okay. Okay. I will try to remember. Can I ask you where you're from? I'm assuming that you're not in America. Oh, Kavoth. Okay, good. Okay, good. Thank you so much. I'm I'm just assuming just because like Lady E's in Sweden. Yeah. It's just interesting like how everybody like Ethan's in the Philippines. Come on, Ethan, go to bed already. All right. Okay. So, if you have any more questions, set them up and we'll go through all the questions. If you have number questions, let me know and we can work it through and I can show you and tell you. It's a Swedish name, but I'm from. Oh, okay. You're in the US. Okay, great. So, yeah. So if you have any if you have any math questions, we can go through it. We can talk about division if you guys are ready. It's a little bit much to do the to do the division because there's more formulas involved. But multiplication, addition, and subtraction. It's a Swedish name. Yeah. So yeah. And yeah, and I do plan on making. And I started thinking about how to make abacus more adult. So I'm going to start making more questions that are more adult driven instead of having like this stuff. But I think I'm still going to make it engaging. Like I'm thinking of still having like color by number and stuff. I don't know. I haven't figured it out. But that was the plan. Like I didn't realize on how interested adults are. So multiplication would be good again. Yeah, multiplication's easy. It's easy and yet it's complicated because you can really get lost in the sauce. But yeah, we can talk about multiplication. When we can talk about multiplication. Try to end off there, depending on how long it takes. Because sometimes the groups become like are really quick and they understand their addition and subtraction, and sometimes it takes a little bit. So we'll go back to multiplication. So that's not a problem. And then we'll have more numbers. Okay, so again, thank you everybody for joining me, and everybody have a good day. Thank you again for all the comments and compliments and the chats and the gifts. Thank you so much for the gifts. I'm not expecting it. I was just one of those things. Like I do really enjoy talking about abacus, but I do appreciate everybody here. Thank you again, and I will see you guys in my next live. Have a good day, have a good morning, have a good night. Go to bed, Ethan, go to bed. And then Lady E, I'm assuming it's daytime for you because you're in Sweden, right? No, it's nighttime for you. It's nighttime for you. Okay, you need to go to bed too. All right, everybody have a good day, have a good night. See you guys all in the next live. Bye.